acute integral for Apery constant. So does this look cute? So basically, cute in the sense that like this integral like nicely reduces to Apery's constant, that is zeta of 3. Since it simplifies so much to such a beautiful value, so that's why I gave it a cute name. Okay, now let's see how do we solve this problem. So basically, to solve this problem we also need dilogarithm function. Yeah, and dilogarithm function is defined as the integral from 0 to x of minus ln of 1 minus t by t dt. Okay, so and now why is the definition so complicated? Minus and minus sign. Basically, this is mainly defined from a sum, yeah, and then from the sum we found the integral. So that's why the integral looks somehow complicated. But sum is not. Sum from n equals to 0 to infinity x to the power n, sorry, from 1 by n square. So this is the sum definition. And if here's anything other than 2, if here's s, we have s over here, and that's called polylogarithm. And I have already introduced these things in the playlist in my channel called polylogarithm, where I've introduced it from very beginning, from very basic level. So if you want those stuffs, please check my playlist, which I link over here. Okay, so now let's solve this integral. Okay, now what this definition also implies it is, so basically if we have integral from a to b of minus ln of 1 minus t by t dt, so this definition also implies that this is just gonna be li2 of b minus li2 of a. That's why li2 of x is just like the indefinite integral for this function. Okay, now let's begin this integral. Integral from 0 to 1, we have log x log of 1 minus x by x dx. Okay, so now if we use integration by parts with this as u and this as b, we basically get log x over here. And I told it already that we can just take the antiderivative, indefinite derivative of this expression as li2 of x, but since there is no minus, we have to add a minus over here, li2 of x, yeah, and going from 0 to 1, and then minus integral from 0 to 1, derivative of log x is 1 by x, and its integral is again minus li2 of x dx. Okay, so now after this we evaluate this at 1 and 0. At 1 log of 1 will be 0, and at 0 li2 of x will be 0, because we know that from sum definition if we put x equals to 0, the whole sum goes to 0. So that's why this is 0 plus 0, and minus minus will again be plus over here. Integral from 0 to 1 li2 of x by x dx. Okay, now from the sum definition you can derive one formula that I've already done in this video over here. So the formula is basically if we have integral from 0 to z of ln, sorry, if lis base t by t dt, this will actually be equal to li s plus 1 of z. Yeah, so if you use this property, this is just gonna be li 3 of 1, yeah, because z is 1 over here. Now how do we find li 3 of 1? We can now use the sum property, that is sum from n equals to 1 to infinity 1 to the power n by n to the power, this is 3 over here. Now we know that this is just zeta of 3, which is the Apery constant, and that is the answer. So basically in this video we used a lot of the polylogarithmic properties integral representation, sum representation, and this thing change of the base of full logarithmic function. Yeah, and yeah, this was how we solved this problem. Hope you enjoyed the solution. Thanks for watching and look forward to seeing in the upcoming videos too.